In this video, we're going to jump right in, and I'm going to show you what I think is the coolest part of Neatoo, and that's the Roslyn Source Generators. We're going to show you how they generate your two-tier factory as you code, and how you can see them and step through them while debugging. So on the left, we have a simple model, our person model, but on the right, we have the factory being generated by Neatoo, and we'll see that it generates it live as we're coding using Roslyn Source Generators. So first, I actually want my create to just call my constructor. So I'll add create. You notice that it catches the parameter. Then I'll do my fetch. So then we get our fetch. One side point with the fetch is actually, since we're returning bool, it'll actually return a nullable. If I didn't do this, just return task, we'll see the nullable disappear. But I want to be able to indicate that I was unable to find the model object. Now upsert and delete are a little different. In this case, whoops, I'm going to be able to add them both. And then we actually get all three of them combined as a save method that takes the target. Of course, we're saving, so we need to be on the server. We're using entity framework, our iPerson context, so we need to be on the server to do this persistence. But this is where it gets interesting, because we could also use this object on the client. We could just bind it to the view and have it actually do things like give us error messages. So this is an interesting point with Blazor. With Blazor, we can run the same libraries on the client as the server. So we can simplify our approach versus JavaScript SPA applications. We can write our domain model class once, bind it to the view on the client, enforce business rules on the client, serialize it to the server, enforce the same business rules, and then call data mapper methods to persist it. This is not a new idea. It originated with CSLA. I've done this for many years with CSLA and WPF, and it works great. Now we have Blazor. I wrote Neatoo with the idea of recreating CSLA with dependency injection and async await from the ground up. Incorporating Roslyn Source Generators is what really set it apart. Before Roslyn, you needed to use reflection. So for instance, any mismatches of types was a runtime error. Now Neatoo can generate the framework implementation code live as you code, as we've already seen. This provides compile errors where there were runtime errors, lets you see the code, step through the code, set breakpoints, find definitions, all of it. It's very beneficial. That's why I wanted to share it. But we haven't yet made our domain model object two-tier. Let's do that now. That said, Neatoo makes making these remote calls very easy. So you'll see here in the factory, the fetch right now just calls local fetch, which actually just calls our method here. But if I come over here and I add remote, now our fetch changes, and Neatoo actually uses a delegate to create the fork in the road. If we want to run it local, we run the method local. If we want to run it remote, we go to the server and we run the delegate. So that quick and easy, this now runs on the server. So now let me add that to these methods. And now all our methods that use our entity framework context will only run on the server. But that still leaves one point to fix, and that's if you look at our factory definition, we actually do take that person context. But of course, we don't want our consumer to provide that. We want that to be from dependency injection to be injected. So the approach is to just add a service attribute. And again, you'll see on the code, you'll see that disappear from those methods. So now it's ready to be consumed by our client. Before we go look at our Blazor client, I'd like to show you another thing that's being generated, and that's these map to and map from methods. Maybe you noticed the map from method down here, and this is mapping us from our object, our domain object, to our entity framework entity and back. And that's being generated by Roslyn as well. And what's nice about having this being generated compiled code is if I go and I change the type, so to catch mismatches like this, the source code is just generated based on property name. So now I'm trying to match an int to a string. Now it doesn't quite show up in IntelliSense, but if I do a build, I do get the error. You cannot convert string to int. And sometimes when you click on it, it will actually bring it to you. This time it did. So again, we're getting compile time errors where before we used to just get runtime errors. So now let's take a look at the client. Through the magic of editing, I've had some dinner, so I am ready too. So we inject our iPersonModel factory, which again, that's been generated by Neatoo using Roslyn Source Generators, both the interface and the concrete, the client, or the implementation. Now we look down here, we have our create, we have our fetch, we have our save, and we have our delete and save. So if we run the application, you can see it's a very basic application with your standard operations. Here we do the create. This isn't remote, so we're still on JavaScript. We're still on the browser. We add in some data, hit update, and now we are on the server. Person.server. We create our entity, and we save it to the database using Entity Framework. We make a change. Hit update. We get back to our upsert, but this time we find our entity and we update it. Clear and we do our fetch. We see we fetch again on the server. Get the data back. Go to our delete. Do our fetch. No data to be gotten. So you can see that we have the standard CRUD operations covered, and we're doing this, we're using the domain model object in both our client and the server, and Neatoo is making the remote call for us and serializing the data back and forth. Now let's look at authorization, and we can see how we can reuse the same authorization that's generated by Neatoo on both the client and the server. So first we'll look at our authentication. So the authentication is independent of Neatoo. So the authentication here is very rudimentary. I'm just going to define a user and pass the user with a call that has a single role. And these roles are, I'll assume, are inherited. If you have delete, you have update. If you have update, you have fetch. So we're mimicking an authenticated user, but we want to authorize these roles. So to define my authorization, I'm going to create a person model auth, in this case, so auth class specific to my person model. First key here is that we inject our user, which is why Neatoo is agnostic to the authentication, because you just inject whatever represents, whatever the source is, and then you tie it together in a very dynamic way. So in this case, I'm making a can access, can I do anything, and then can create, can fetch, can update. And you're allowed to do this if your role is greater than or update or equal to. So if I can update I can fetch, so on. But as you've noticed, the key are these attributes. So this authorization, authorize operation that decorates these, pretty standard, create, fetch, insert, so on. And so like in this case, this method I want to call whenever I do a read or a write. This one whenever I do a create, this one whenever I do a fetch. So we actually want to call this method and this method on each fetch. So this is the class that defines my authorization, but how do I link this back to my person model? So if I go back to my person model, again we have our factory over on our right. This is going to lead to some big changes. So if I go and I add authorize and I give it my type, it's going to match the two classes, and it's going to recognize, and it's going to add our authorization. So not only does it add the authorization, it adds the information that the UI needs. But if we look at the definition, like we said, we want fetch to call two methods. Oh, that's not working. And we can see that it's calling can access and can fetch. So now, how is it making the connection? Well, if we look at fetch here, and we look at this factory operation.fetch that it represents, we can see that this is actually is a bitwise of fetch and read. So it's calling can access because that's decorated with the read, and it's calling fetch because it's decorated with the fetch. So now let's take a look at our client. So we'll see I added a way to select our role. So if I upgrade our role to fetch, that allows me to do a create. Now I'm on the client because create doesn't go to the server, nor does our auth. And I'm checking can access and can create. My user role is fetch, so that's okay. So now add some data, but I don't have the update role. So I hit update. Can I access? Yes. Now I'm on the server with this. So we have made the trip to the server, but my role is fetch. So on my update below, I failed. So we can see that this is enforced at the domain model level. It's defined once and enforced on both layers. So now let's use this information to prevent authorization failures. So if I go back to my form, I have the buttons, create, fetch, and clear, create, fetch, delete. I do have them bound to some can variables. Have them all set to true. Of course, we don't want that. Oh, don't want these. And then down here, again, your authorization, or excuse me, your authentication wouldn't likely change as the app is running. So there's some quirkiness here just to handle that. So you can ignore that. But each time our role changes, we check through our factory what we have access to. So again, this is that generated factory. We're seeing what we have access to. So now if I run the app, now my buttons are disabled. And as I do this, now it calls the same operations that it calls when it goes to the server. But this time, it's just to get whether or not you actually do have access. And I'm calling all of them, so I end up getting a bunch of calls. Let me delete my breakpoints. So now here, instead of being able to have a failure, I just simply can't click a button. And if I can click the button, it's the exact same definition as what will be done on the actual operation to the server. It's defined at the domain model layer. There you have it. We now have a two-tier client-server Blazor application. With Neatoo, we are able to make our domain model object dual use. It works with the view using data binding and works with the database in the factory data mapper methods. We didn't have to define DTOs. We didn't have to define controllers with specific REST endpoints. We never do, even as we define additional domain models. Plus, we have authorization. It's a lot less code, and we didn't even cover Neatoo support for complex business rules. So, what do you think? Is it exciting, or is it a bad idea? Please let me know in the comments, and thank you for watching.